Alright, we're going to solve absolute value inequalities. This is a little bit of a tough concept for some students, but I'm going to try to do it graphically rather than a straight algebraic approach, because this kind of makes us visualize it. First thing we need to do is remember what an absolute value graph looks like. So here's the general equation, y equals the absolute value of x, and what that does is produce just a v. I'm just interested in the shape, right? 0 in, 0 out, 1 in, 1 out, 2 in, 2 out, negative 1 in, 1 out, negative 2 in, 2 out. So right there's a v. Now what we're going to do is take this and break it into two equations. Y equals the absolute value of x plus 1 and y equals 2. So I've written them both there. The subscripts just means two different y values. Okay. Now what we're interested in is if I graph this by itself, here's the absolute value graph, and if I graph this by itself, there's y equals 2. Now you'll see that the y equals 2 is a horizontal line, and it breaks the graph into two parts. Values that are greater than 2 for the y values, right? Look at 3, 4. These y values going up are greater than 2, and values that are less than 2 are below the line. Now you'll notice the absolute value graph has two parts. Parts that are above the line, y values that are greater than 2, y values that are greater than 2, and then y values that are less than 2, below the line. So if we want to solve this equation here, x plus 1, the absolute value of x plus 1 is greater than or equal to 2, what we need to do is just find this point here and this point here where they're exactly equal to 2. And on my graph I can see it's at 1 and negative 3. And then after that, look at x equals 2. What's my y value? Well, I don't know what it is exactly. Maybe it's 3. It's greater than 2. Over here, what's my y value at negative 4? It's greater than 2. It's 3 again. At negative 5, it's greater than 2. At positive 3, it's greater than 2. So this is the solution here that is greater than 2. Greater than or equal to 2 includes these 2 points. So x is less than or equal to negative 3 this way, makes y values greater than 2, and x is greater than or equal to 1 this way, makes y values greater than 2. So the interval and inequality solutions to this graph, or this equation and graph, are right there. Now if we move on to another example, let's say solve this one, absolute value of 2x plus 4 minus 2 is greater than 8. What we need to do is get it to where it's just an absolute value. So I will add the 2 on both sides, and now I have absolute value of 2x plus 4 is greater than 10. Now I'm going to break it up. Remember, I have my v and I have my line. My line is the 10, y equals 10. That's above 10, below 10. My v is my absolute value. It's not graphed perfectly, but I don't need it. I just need an estimate there. Now I got to find these spots right here. Where is it equal to 10? That's this spot right there and there. Where does this equal to 10? So I go to absolute value of 2x plus 1 plus 4 equals 10 and split it into the two cases. I solve that. I find it's equal to positive 10 here at 3, and it's equal to a positive 10 when x is negative 7. Alright, so now I look at the graph. I have negative 7 gives me a 10, positive 3 gives me a 10. Now remember, it said greater than 10. When is this greater than 10? Here it's greater than 10, the y is greater than 10. Here the y values are greater than 10. What x values produce them? Well, I found this point to be negative 7, so negative 7 over makes y greater than 10. I found this point to be a 3, so 3 and to the right make the y values greater than 10. So that's my solution. X is less than negative 7, or x is greater than 3. My interval solution, negative infinity to negative 7 union with 3 to infinity. So here I have one for you to try. If you'd like to try this one down here, work it out yourself. Draw a V, draw a line, and then I label that line 3. That y value is 3. Now I want to find when is this greater than 3. When is it greater than 3? Well, of course, in this area here. So you just got to find out this point, and basically you can write the answer.